Okay, lesson 7.3 is proving that a quadrilateral is a parallelogram. So it says identifying and verifying parallelograms. Given a parallelogram, you can use the parallel opposite sides theorem, which is theorem 7.3, and the parallelogram opposite angles theorem, which is theorem 7.4, to prove statements about the sides and angles of the parallelogram. The converses of the theorems are stated below. You can use these and other theorems in this lesson to prove that a quadrilateral with certain properties is a parallelogram. Okay, so if we have done chapter, it would be 2 at this point, you would remember that a converse is just whenever we switch the order that our hypothesis and conclusion go in. If we have not done chapter 2 yet, then just know that we're going to take the old theorem and basically flip-flop what comes first, okay? So that's what a converse is. So it's going to sound a whole lot like your original theorem. It's just kind of backwards. So this time in theorem 7.7 for parallelogram opposite sides converse, we're told this time that if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Okay, remember before we were told if it's a parallelogram, then the opposite sides of a quadrilateral are congruent. Okay, so it just flipped the order. Same thing here, theorem 7.8, parallelogram opposite angles converse. If both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Okay, so then if we come down here to example 1, it says an amusement park ride has a moving platform attached to 4 swinging arms. The platform swings back and forth higher and higher until it goes over the top and around in a circular motion. In the diagram below, segment AD and segment BC represent 2 of the swinging arms, and segment DC is parallel to the ground, which is line L. Explain why the moving platform, segment AB, is always parallel to the ground. Okay, so we see that the shape of quadrilateral ABCD changes as the ride swings around, but the side lengths do not. The opposite sides are congruent. So ABCD is a parallelogram by 7.7. Okay, that's theorem 7.7. Okay, so then it says explain why the moving platform is always parallel to the ground. Okay, so then by definition, segment AB is parallel to segment DC. And they told us that segment DC is parallel to L, which was the ground. So that means that segment AB is parallel to L, the ground, by the transitive property. Okay, so again, if we haven't done chapter 2 yet, you aren't familiar with the transitive property. Okay, but basically what it's showing you is that if AB is parallel to DC, then you can see that DC repeats itself here, is parallel to L. Then we can cut out DC, what's in common, and we can just say that AB then would be parallel to L, okay? Because we know if these 2 are parallel and these 2 are parallel, and these are repeating itself, then these 2 also have to be parallel, okay? It only makes sense if we think about it, okay? So that's what the transitive property is discussing. Again, if you don't know that yet, that's that, or it's a good reminder if we have done that chapter, okay? So go ahead and flip the page. Example 2. Okay, it says, for what values of x and y is quadrilateral PQRS a parallelogram? Okay, so we want the opposite sides to be congruent, okay, or the same length, right? So we are going to figure out, here's a y, okay, and here is x plus 7. Well, I can't put those two equals to each other because that would give me two different variables. So instead, here I see a 2x plus 1, and I see an x plus 9. So let's use that first to help us find what x is. So x plus 9 equals 2x minus 1. Okay, so I am going to add 1 to both sides. So I get x plus 10 equals 2x. Subtract 1x, and you get 10 equals x. Okay, well now I can go over to the other one, y equals x plus 7, because I know what x is now, so y equals 10 plus 7, so y is 17. Okay. Theorem 7.9 is the opposite sides parallelogram and congruent theorem. So if one pair of opposite sides of a quadrilateral are congruent and parallel, then the quadrilateral is a parallelogram. If theorem 7.10, parallelogram diagonals converse. If the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. Okay, example 3. It says the doorway shown is part of a building in England. Over time, the building has leaned sideways. Explain how you know that SV is equal to TU. Okay, so it says in the photo, you can see that ST is parallel to segment UV. Okay, and that is indicated by the little arrow. Okay, so I guess I should come back up here and show that too. This little arrow means that they are parallel. The little segment sign means that it is congruent. Okay, so the arrow means parallel. The little dash on the segment means that they are congruent. Okay, so it says in the photo, segment ST is parallel to segment UV. And segment SV is congruent to segment TU. Or sorry, not TU. That's not what I want. ST. Sorry, I was looking at right above it. Here, I'm just going to cross that off so it's not so messy looking. Okay, what I wanted to say is segment ST is congruent to segment UV. Okay, because again, you see the arrow and the dash combination. Okay, so that means that they are both parallel and congruent. Okay, again, so that's ST and UV. So in the photo, segment ST is parallel to segment UV and segment ST is congruent to segment UV. So it is a parallelogram by 7.9 if it is a parallelogram, then SB is equal to TU by 7.3. Okay, and that was the opposite sides congruent. Okay, all right, example 4, finding diagonal lengths of a parallelogram. For what value of x is quadrilateral CDEF a parallelogram? Okay, so these are the diagonals, and I know that I want the diagonals to bisect each other, okay, or cut each other in half. So I want these to be equal to one another. Okay, so I'm going to add 8 to both sides. So it's just going to become positive 8 over there. And the reason I do that is because I want to move this 3x over here to get 2x equals positive 8. So then x is equal to 4. Okay, turn the page. We have this chart here. Okay, so we have a bunch of different ways to prove that a quadrilateral is a parallelogram. We've talked about a lot of different theorems, okay? So by the definition, okay, by the definition of parallelogram, both pairs of opposite sides are parallel, okay? And to prove that, again, we can see these arrows here. To prove that, we would have to do 4 slopes, okay? And the slope formula is y2 minus y1 over x2 minus x1. Okay. Number 2, by the parallelogram opposite sides converse, we have to show that both pairs of opposite sides are congruent. Okay, or that means that they would have the same length. Okay, so this time we would have to do 4 distances. Okay, and remember this is your distance formula, big square root, x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Okay, again, all underneath the square root. Okay, then the third one would be by the parallelogram opposite angles converse. So that would be both pairs of opposite angles are congruent. And that we would prove using trig. So I'm just going to put in A because we're not going to do that here. Okay. Number 4 is by the opposite sides parallel and congruent theorem. Okay, so in this theorem it says that one pair of opposite sides are both parallel, I'm going to do the abbreviation, and congruent. Okay, so for that one we would have to do 2 slopes and 2 distances. Okay, and the 5th one is by the parallelogram diagonals converse. This tells us that the diagonals of a parallelogram, diagonals bisect each other. Okay, well, if the diagonals bisect each other, they're cutting each other in half, so they meet at the midpoint. So we would do 2 midpoints. And here's your midpoint formula. Okay. All right, so in example 5, it says show that quadrilateral ABCD is a parallelogram. So if I look up here, I have all of these different ways that I could do it, okay? If I'm really good with the slope formula, maybe I'm gonna show that I have 4 slopes where 2 of them are the same and then the other 2 are the same, okay? Maybe I would do 4 distances if I really liked doing the distance formula, okay? 2 of them, you should get the same answer. The other 2, you should get the same answer. Maybe I really like doing both of those, so I'm going to do a little bit of both, and I would do 2 slopes and 2 distances. But maybe if I just want to get this problem over with and I want to prove my point in the quickest way possible, you'll notice that I only have to do 2 things on this one, okay? Every other one I have to do 4, okay? So this very last one might be the one that I pick. So I'm going to select this one. Because I just want to do 2 midpoints. Okay, so now notice though, this is like the biggest thing that people mess up here. They know to do the midpoint and they know how to do the midpoint formula, but they don't pick the midpoint of the diagonals, okay? So I want to pick points that are opposite of each other. So maybe I'm going to do the midpoint of AC, and then I'm going to do the midpoint of BD. Okay, so the midpoint of AC, capital M, would be -3 plus 5 over 2, 3 plus 2 over 2. So that would give you negative 3 plus 5 is 2 divided by 2 is 1. 3 plus 2 is 5 over 2 is not divisible. So I'm going to leave it just like that. Okay, so now the midpoint of BD, I'm going to call N. So that would be 2 plus 0 divided by 2 and 5 plus 0 divided by 2. So N is 2 divided by 2 is 1 and 5 over 2. Okay, so now I'm not done though. Okay, so you show me that these two diagonals have the same midpoint. Sure, great. But what does that mean? What is it truly telling us about this shape? Okay, well, that's telling us then that the diagonals bisect each other since they have the same midpoint. So ABCD is a parallelogram. Okay, that is really your final answer. Okay, this is what I have to have in order for you to get all of your points. Okay, again, you have all of your other choices too, but this is the fastest way I would think. And then so say that you gave me 2 slopes and 2 distances, well then you need to tell me that that's showing you that the opposite sides are both parallel and congruent. Or if you showed me 4 slopes, you would say, okay, that's showing you that both pairs of opposite sides are parallel because 2 slopes are the same and then the other 2 slopes are the same. Okay, so something like that, but you have to describe to me what that math is showing you according to these definitions and theorems. Okay, so if you have any questions, let me know. But yeah, okay, so go ahead and go do your assignment.